function that I'm hoping you will be using to determine all these without, and I should have written here m if you're using the slope. So can anyone dictate? So obviously we want to determine the limit of this as x approaches 2 from either side, from this side and from this side. And you will be determining the slopes. Can anyone give us the function that you will plug in the graphing calculator to determine the secant, the slopes of all secant lines? What is the function? Can anyone help? It's okay if you're wrong. Anyone?
It would be, let's say,
This is our function, right? So we are determining what happens at 2.
Just plug 2 in to get the raw values, right?
So when I plug in 2 in here, I have some difficulties, right? Here's why. So let's write it. So x squared minus 4 divided by x minus 2. Because obviously I have to have the function. This portion must be f of 2, but I can't plug in 2 in here. And the denominator must be x minus 2. Okay, so here's our function. And I have here a point, q, which is 2 f of 2. Right? And I have another point, which is p, x comma f of x. So I will create this function that gives the slope of the secant line. So the slope of the secant line, pq, will be f of x minus f of 2 divided by x minus 2. Do you agree with this? So that's what I'm trying to put in here. F of x, I copied it, minus f of 2, but I have to determine this, over x minus 2, x minus 2. But I have to determine this first, and then I can plug it in the calculator. So I have to come back and simplify the function. How do I factor the top? Very good. What do you think I'm going to do next? Simplify x minus 2. And the simplified form is x plus 2. So therefore, I can now determine f of 2. Can anyone tell us how much is f of 2? 4. So here's your function. This is what you would be putting in the graphing calculator as the slope of the secant line, and you will approach to determining all these. Yes, please. It's undefined. I have 2 minus 2 in the denominator. I can't plug in 2.
So that formula right there is the secant, right?
It's the slope of the secant line.
So,
Yes.
So I don't have to write the x squared minus 4 over x minus 2, but I can write x plus 2 over.
Yes, of course. Of course, but I wanted to explain how we get it. Yes, so you can go ahead now and replace this by x plus 2. And x plus 2 minus 4 will be x minus 2, and x minus 2 over x minus 2 will be 1. So the slope will be? Yes, please.
Where does the 2 come from? F of 2.
This one?
Yeah.
Okay. So in order to determine the slope of the tangent line at this point, I need to create another point. I need to determine the slope of the secant line. So if this point is on the graph and its coordinate is 2. Its x coordinate is 2, then the y coordinate must be f of 2. Then I create a point on the same graph with coordinate x coordinate x. Well, it means that the y coordinate must be f of x. Now I'm trying to determine the slope of the secant line. The slope of any line given 2 points is f of x2 minus f of x1 over x2 minus x1. That's the definition of the slope. y2 minus y1 over x2 minus x1. So I have the point Q, which is 2 comma f of 2, and I have the point P, which is f comma f of x. This is my first point, so this is my x1, y1, and this is my second point, which is x2, y2. y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. Was that the question? And now f of 2, I cannot plug in 2 in here, so I have to simplify it. I notice that the numerator is factorable. I notice that one factor goes away. I notice that the final simplified form of this function is x plus 2. And when I plug in 2, I get 4. So this is f of x, which is this quantity. And this is 4, which is this quantity. And then I copy x and 2. Everything revolves around finding the slope of a line so far. Is that better?
Yeah, I'm just gonna have to.
Which part is not clear?
A lot of it.
So is it the way we determine the slope of a line, or? Well, we have to review then the slope. y2 minus y1 over x2 minus x1. That should take you 5 minutes. Okay, so then you can fill in this, right? We are going to do it algebraically, which we already did. So we will have the answer right here in a blink. We did it already, but let's do it one more time. Limit as x approaches 2 from either side of x squared minus 4 over x minus 2. This is the rule with any limit. When I'm asked to find the limit, I must plug in this number. And you should be appalled. And you should say, no. You just told us that x approaches 2, but it does not equal 2. So when we say x approaches 2, we mean gets closer and closer to 2. But you are not allowed to replace it by 2. However, I'm going to do it. And I will always do it, because I need to see what type of limit I'm facing. I'm not going to tell anybody I'm doing it. I'm not going to write it anywhere, but I have to do it. So I'll stand here and look and say, okay, if I plug in 2 at the top, I get 0. If I plug in 2 at the bottom, I get 0. Oh, this limit is 0 over 0. If it is 0 over 0, I will write yourself. I would like you to write this note. There is hope for the limit to exist. Because if I manage to remove the factor from the top and remove the factor from the bottom that creates 0 over 0, the limit may exist. I'm not guaranteeing. I'm not saying if it's 0 over 0, the limit will always be 5 or 3 or 10. No, I don't know that. But I'm saying there is hope. In which situation there is no hope? In situation, any number you want, not 0, divided by 0, not 0, not 0. In this situation, there is no hope. For this limit to exist. This limit will never exist. Will either be infinity, or it will be negative infinity, or it will be d and e. So this is one option, option 1, and this is option 2. So 0 over 0, there is hope for the limit to exist. a number over 0, there is no hope for the limit to exist. So I'm coming back here. I see 0 over 0 when I plugged it in. So I'll say, okay, there is hope. I will continue with the limit as x approaches 2. I will repeat what I just did a minute ago. X minus 2, x plus 2 over x minus 2. I will, of course, simplify. I'm allowed to because this x is not 2. And then I get that this is the limit as x of x plus 2 as x approaches 2 from either side. What is the answer? If x approaches 2 from either side, the function values x plus 2, what will they approach? Oh, of course. So I already know the answer. And of course, all these numbers going back, going closer and closer, what will they approach? Exactly. So I did this algebraically by simplifying the function. I did it with plugging in the graphing calculator, the numbers closer and closer to 2 from this side and closer and closer to 2 from this side. So I put in here the syntax or the command for finding a limit. So you can find a limit with Maple. I created this function, a simple function, 2x plus 4. I denoted it by f. And then I said to Maple, limit f, find the limit of f when x is 1 from either side. So what do you think this, without even looking, I covered it. As x approaches 1 from either side, what function value will f approach? 6. 6. Okay. Yes, please.
X is undefined, should
Say it again. When x is,
when the limit is undefined, should be
there is no limit that is undefined.
well,
The limit is a number. It can be infinity, negative infinity, or does not exist.
So when the limit is 0 over 0,
Yes.
should we always simplify first and then plug in x?
No, you have to plug in. You have to plug in the value first to see what type it is. That's number one. Number two, you have to simplify it, and then you will plug in again to see if it's a number. If it's a number, you're done. If it's not a number, then there are other options. Yes, we're going to go over the options. So the options will be depending on the function. So it all depends on the function. Yeah. Yes, any other question? Okay, then I plotted this function. This is extremely important. So, and here's the graph of this function. So the function is f of x equals sine x over x. What can you say about this function? Very important, and we have to remember this. What can you say about this function? It's a combination. It's a rational function, but it's a combination with a trig function. It has a trig function at the top. It has x in the denominator. So it's definitely rational, but it also has a trig function in it. But what can you say about its domain? Excellent. So the graph is lying. Well, of course, it was kind of big when I copied it from Maple, so I had to minimize it a little bit because otherwise I would have given you like 20 pages. So obviously it has an opening right here. The function is undefined at that point. It cannot have a point. So the numerator is 0, the denominator is 0. Okay, but now I'm asking you to tell me what is the limit as x approaches 0 from either side from sine x over x. Look carefully at the graph. I will show you how to determine this limit without a graph, but I can't right now. We don't have everything we need. How much? Right. So we have to draw here two conclusions. One conclusion is that the limit exists even if the function is undefined. So we said clearly that the function is undefined at 0. However, the limit exists. So it does not matter whether the function exists at the point, it has no meaning for the limit. So the function can have an open point, but as long as both sides approach that same point, the limit exists. So as you see, both function values from left and right approach 1. However, the function is not defined at 0. So as x approaches 0 from either side, the limit of the function is 1. So one thing is, the function doesn't have to be defined for the limit to exist. Number 2, this limit is a very important limit. It will appear a lot in the course. So please remember it. The limit of sine x over x as x approaches 0 is 1. Also the reverse, x over sine x. The limit of x over sine x will be 1. So now I showed you the next step. So I did not put it in, so you can put it in, which I did. Here is the command for finding the limit from the right or finding the limit from the left in Maple. Limit of sine x over x. Careful when you plug in, when you type in sine x, it has to be in parentheses, like the absolute value in parentheses x, as x equals 0 from the right. In the same way, the same command will be for the left. And in both cases, you will get 1, of course. Okay, next step. Here's a theorem that says the limit of f of x as x approaches a from either side is L. This is not something I created. This is a mathematical abbreviation. IFF means if and only if. So if the limit exists, in other words, is a number, not infinity or DNE, then it means, which makes sense, that the limit from the left is L and the limit from the right is also L. So when I say the limit from either side is 1, I'm automatically telling you the limit from the right is 1 and the limit from the left is 1. So if I'm telling you the limit from the left is 1 and the limit from the right is 1, I'm telling you that the limit from either side is 1. Okay, I wrote on top of this, and I should have not done that. So now the next item on my list is an example, which is our example, our problem that we worked on. And I just copied the graph one more time. So this is from our previous readiness quiz. And I'm asking you to find the following limits if they exist. And now I'm going to write it here. So for that graph, I want you to tell me how much is the limit of f of x as x approaches 0 from the right. Look at the graph and please tell me, or look at the function. Better, how much? So 0 from the right is 1. Very good. Do you all agree with 1? 0 from the right. Yes?
How did you get 1?
Look at the graph. You have the graph in front of you? So my problem is that I wrote on the other side. So as you see, the function values as x approaches 0 from the right, the function values approach 1.
Oh.
Okay. Limit of f of x as x approaches 2 from the right. Can you please read 2 from the right? Stop me if you have questions. 2, the limit of f of x as x approaches 2 from the right. Say it again. Excellent. The function doesn't have a graph. It does not even define there. So there is no contradiction here. I said the limit of a function exists even if the function is undefined at that point. But I have to show that the function exists. It may not exist at that point, but the function values have to approach a number. But it's empty on the right-hand side of 2. There is nothing there. So the function doesn't approach anything, right? Are you with me? Okay, part C, f of 0, please. What will you say about f of 0? Careful, look again. Look again, f of 0. Careful. Right here. Exactly, right? It's 2. That's x, f of 0. When x is 0, y is 2.
And it's not 1 because 1 is also 0.
Yes, exactly. Do we all agree with f of 0 being 2? Okay, very good. Next one. Limit of f of x as x approaches 2 from either side. I have to show the function coming towards the same point from either side. Can I do that? No. So what do I conclude? Does not exist. Limit of f of x as x approaches negative infinity. Very good. Do you all agree with that? As x approaches negative infinity, the limit is 2? Yes? Is that clear? Okay, look here for one more time. So as x approaches negative infinity, function values approach 2. Is that okay? Limit of f of x as x approaches infinity. That is infinity indeed. Right? Let me explain why. So the function to the right is x plus 5. As x approaches infinity, what will x plus 5 approach? If x approaches infinity, what will x plus 5 approach? Of course. And then what will the square root of x plus 5 approach then? Of course. Very good. Moving on. So these are the infinity limits, and I would like to stop for a second and look at some problems. And my problems are right here. Determine the infinite limits if they exist. So the very end. So let's look at limit 6 divided by x minus 5 when x approaches 5 from the left. Okay. So the question is, I'm asked to determine a limit. What do I do first? Can anyone remind us? What do we need to do first when? Plug it in. I have to, even if I don't show it or whatever, I have to plug it in. And I see 6 over 0. I know exactly what will happen. There are 3 options in 6 over 0. What are the options? Exactly. Perfect. So I know exactly that this is not the case 0 over 0. There is absolutely no hope for the limit to be a number. When we say the limit exists, the limit has to be a number. If I tell you the limit is infinity, you have to say, which means it does not exist. And I will have to say, yes, it does not exist, but in what way it does not exist is infinity. Okay? So 6 over 0 has no hope. So these are one of the, it has to be one of these 3 options. Okay. In that case, I'm going to say, I'm going to do this. Let's see what happens. 5 from the left. Can you give me a number very close to 5 from the left of 5? Exactly, 4.9. Please plug in 4.9. Just imagine you plug in 4.9. The top is 6, and the bottom will have what sign with 4.9? Negative. So a positive number over a negative number. What sign do I get? So the answer is negative infinity. Any questions?
Or on an exam, we get a question like that.
That's all you have to do. Yeah, there is nothing else. Yeah. So the next one, limit as x approaches 0 from x minus 1 divided by x squared x plus 2. Okay, this is another example, another limit. First I have to look at this limit. I'm looking at it. I plug in 0. The top turns out to be, and the bottom turns out to be, how much?
0.
Perfect. So I know that there are 3 options, none of which I have a success, right? This limit does not exist. But the answers are D and E, infinity, or negative infinity. Okay. Because the limit is determined from either side, I must determine the 2 limits, the left-hand limit and the right-hand limit. Which I did not have to do this here because this was already a left-hand side limit. But here this is an either side situation. So I must find limit as x approaches 0 from the right, as well as limit as x approaches 0 from the left of x minus 1 over x squared x plus 2. Okay, so now I plug in a number from the right-hand side of 0. Very close. You cannot say 5. You have to say 0.1. What is the sign of the top when I plug in 0.1? The sign of the top is negative. 0.1 minus 1 is negative. The sign of the bottom, how much? Positive. So I know that the situation is negative 1 over 0. So negative divided by positive will be sign. Oh, negative. So the answer is negative infinity. I repeat, for 0 from the left. Give me a number close to 0 from the left-hand side of 0. Perfect. The numerator is negative. The denominator, this is positive, and this happens to be positive as well because negative 0.1 plus 2 is still positive. So the answer is also, it happens to be negative infinity. Both are the same. If this were positive and this negative, or if they were not the same, I would have said here D and E. But since left and right are the same, what will I write here? Negative infinity. Any questions? Okay. And one more here. I have limit cosecant x as x approaches pi from the left. Since it's a left-hand limit, yes, please.
So real quick, when there is when there's x is approaching 0 without
From either side,
either side,
I have, and it's an indeterminate, and it's a number over 0. I have to determine both,
okay.
because if they are both the same, then the limit is that. Still does not exist, but it's that infinity. But if one of them is positive infinity, the other one is negative, and I'll show you examples, then you have to write D and E.
Okay, so if one's positive and one's negative, it's
If they are the same, you copy.
okay.
If they are different, then you have to write D and E. Yep. Yes, please.
That only applies for either side when we have 0 in the limit.
No, you can have x approaches 5,
Okay.
but it approaches from either side.
So why didn't we do that for the for A?
For this one?
Yeah.
Because it's on one-sided limit.
Oh, I'm sorry. Yeah,
That's okay. No.
my handwriting.
We have to review. We have to go over things more than once. So for this one, because it was a one-sided limit, I didn't have to care about the other one. But here, because it's from either side, I have to determine both. Because they will not always be the same. And I'll show you an example in a minute. I still have a few minutes. Yes. Okay, so let's look at this one. This is one-sided limit. I don't have to worry about the other one. But I have to remember what cosecant is. Anyone remembers a ratio that represents cosecant? It starts with C, so it must be 1 over. If it starts with C, it must be sine. Very good. Perfect. Okay, so I plug in pi. I have to plug in pi to see what happens. So here is pi. Here is pi smaller. And here is pi bigger. So it says pi from the left, which means we are in the second quadrant. Because it's with smaller than pi. This is pi smaller than pi is in the second quadrant. So we are talking about this. What does sine pi equal to? So it's 0, right? So this is 0. So this is positive divided by 0. It's positive 1. I shouldn't put positive here. I mean, we are not replacing yet by anything. So it's 1 divided by 0. Does this limit have any hope to exist? No. So I'm looking at 3 options. Positive infinity, negative infinity, or DNE. Since it's from one side, most probably is positive infinity or negative infinity. Okay. So then now I'm thinking of what is the sign of sine in the second quadrant? Because pi smaller than pi, we are here. What is the sign of sine in the second quadrant? Is it positive or is it negative? Sine is measured on the y-axis. So sine is positive here and it's negative here. So it's positive. So 1 divided by positive. What will be the final answer? What? Perfect. Very good. And I think I have time to show you since you asked. Again, I don't seem to finish. I already have the next handout for you. I didn't finish this one. But since I have it, I want to give it to you right now. Because you asked that question and we have time to work on one problem. Right? So you said, why do I have to determine left and right? The limits when the limit is asking us to find when we're asked to find the limit from either side. Okay? So I'm jumping ahead just to answer your question. And I'm looking on the second page of this handout at problem 5B. 5B. I know it says 0 from the right. I can change it just to show you what happens. 0 from either side. And then I'll stop. I think I can finish this problem. So here it is. We're asked to find the limit as x approaches 0. I'm going to change it for now just to make a point. 1 over the absolute value of x. Okay, so the requirement here would be to simplify this function first. So I'm not even looking at this before I simplify this function. Where do I start to simplify this function? Where is the starting point?
Absolute value.
Of course, absolutely. What are the options for the absolute value of x? Very good. If and if. Excellent. If and if what? If or equal to 0. And the other option is No, I cannot have equal in both sides. Less than 0. Perfect. That was the first step. Here's the next step. Now I have to simplify 1 divided by the absolute value of x. Can anyone give us the options? Knowing that the absolute value can be either x or negative x, what are the options now for this expression? Well, obviously 1 over x, or the other option is negative 1 over x, right? 1 over negative x, which is negative 1 over x. However, now I can no longer write the equal symbol here. That's not an option anymore. Why? Why I was able to write the equal symbol here, but I'm not able to write the equal symbol here? Can anyone explain? Exactly. Perfect. So now I'm one step closer to simplifying this. So can anyone give us this simplified form of the entire function now? I took it piece by piece, and now I'm putting everything together. So I have to write 1 over x minus 1 over x for x greater than 0. And then I have to write 1 over x minus minus, so plus 1 over x for x less than 0. So the simplified form, this is simply 0 for x greater than 0. And this is 2 over x for x less than 0. After all this work, I simplified the function, and now I'm asking you, how much is the limit as x approaches 0 from the right, and how much is the limit as x approaches 0 from the left? Which function do I use from 0 for 0 from the right? I can only pick one. Which of these two?
Top one, 0.
And what is the limit as x approaches 0 of 0? Of course. And now 0 from the left. Okay, now I have to think. I have to remember how to graph 2 over x. Or you can say, okay, I plug in 0, I see it's 2 over 0. Or you can think of the graph too. So 2 over 0, I know the limit cannot exist. It's either infinity or negative infinity or dne. So now 0 from the left, I plug in a number close to 0 from the left, and I get negative 0.1. Positive 2 over negative 0.1. What will the answer be? Very good. And now I'm ready to write the final answer. The question was, limit as x approaches 0 from either side of 1 over x, 1 minus 1 over the absolute value of x. What would you write? I had to determine both. I was asked to determine the limit from either side, and I had to determine the left limit and the right limit. What will you say from either side?
0.
Yes. They're not the same, right? They must be the same. If the left is 0 and the right is 0, then I have to write 0. But since from one side I have 0 and from the other side I have negative infinity, I must write dne. So this, I think, answers your question. So every time I'm asked to find the limit from either side, and I have that situation with a number over 0, because I had to simplify. I had to simplify all this. Because 1 over 0 minus 1 over 0 is undefined minus undefined, right? So that's why I had to simplify the function. But because the limit we were asked to determine the limit from either side, I had to analyze left, I had to analyze left, I had to analyze right, and then make a conclusion. So in the previous case that we worked on, it happened that both sides were negative infinity. That's why we copied negative infinity. But in this case, we had 0 from one side, negative infinity from the other. Therefore, it's dne. Any questions for me? My plan for Monday is to finish these two handouts and then move on. I wanted to remind you that I have copied the same thing in both handouts. I would like you to finish this and work on at least the problems that you can from here. I do have a couple of things that I didn't get to, like this is in Canvas. Yeah, I can make you a copy if you want, or you can have this one. So there are a few other things that I wanted to go over. I only have 1 minute, so I will not be able to finish. I wanted to refresh your memory on graphing rational functions. So that's why I graphed the horizontal asymptote as well for this function and analyze it and answer some questions. This was an exponential function I put in here so I can refresh your memory on how to graph exponential functions. This is a log function. This refreshes your memory on how natural log looks like. This is the famous tangent and, of course, arctangent. So these are famous functions, tangent with a vertical asymptote, and of course arctangent with the horizontal asymptotes. And these are functions that are called hyperbolic functions. So I wanted to give you the definition of these three functions. And the rest, you can finish everything. You can finish everything in 2.1 and 2.2. So I only had some graphs to look at. We already solved a problem like this. I will solve it with you next time. But you can finish all these problems and turn them in for 2.1 and 2.2 on Monday.